Alright, welcome to Visual Basic for Level 2 Concepts Required here at Hamilton Boys High School. Tonight we're just going to go through and take a little look at some of the Level 2 concepts that are needed to do well in NCEA, striving for excellence and merit type grades. So the items that you learnt last year served as a good building block for coming into our Level 2 course. So things such as sequence, the use of loops, the use of variables, the use of if and conditional statements, all of those serve as our foundation coming into this course. And the main step-ups that we need to look at for going into Level 2 is the use of collections, such as the use of lists or arrays, and also the use of called procedures or subroutines or functions, depending on the language that you'd like to be using. So here within Visual Basic we'll refer to those as subroutines and functions. Subroutine is this item here. You can see that we've got a submain, which is pretty much all we've been working up to into this point, but towards the end of this tutorial we'll start looking at how we can actually break down our problem using additional subroutines and functions to make our programs more meaningful, be a bit more robust they call it, which means that you can throw more things at the program and it can handle it, and it can also grow and expand over time using good flexible naming conventions and variables. Okay, so just to introduce you first off to the use of collections, we're going to focus primarily on the use of lists rather than arrays. Lists I find are a lot more flexible. They can be kind of expanded and contracted a lot more easily, and I think for our purposes they'll work fine. So one of the examples that we've probably done in the past is the use of a program which has stored a person's age, and we've gone through and stored those as a range of integers through our program. The problem that we might have is if we're wanting to maybe have 5 or 10 or 1,000 ages entered into our program, it quickly becomes limited in the fact that we'd have to make lots and lots of different variables to be able to store those. So the concept that we'd like to cover instead here is the use of something called a list. So I'm going to give it a generic name of my list. We want to try and use lists just like variables, and the fact that we want to give them names that with names that make sense. And then the context that we're going to use here is we use the keyword as new list, and you'll see in this drop down box that's appeared it's saying list of t. So the of t means tell us the type of list that you'd like to store. So if you'd like to store a list of integers, which we are here, we'd be storing a list of integers, and we can go through and place that within these rounded parentheses, and you'll notice the keyword of popping up here now. So that's trying to give you some prompts for the types of things that we're able to plug into this list here at this point. If I was just to go through and copy and paste these down, a list can hold pretty much all the different data types that we've dealt with at this point. So if we could go through and store a list of booleans, we could go through and store a list of decimal numbers if we're wanting to, and each of these being given a probably a slightly different name. So if I wanted to go through and actually give a more meaningful name or something that I can actually use again and again, I might like to just go through and specify them like so. So the great thing with lists is that when we want to go through and add something into our list, it's quite a simple process. We use the key term for our list, and then we push the dot property, which will bring up all these useful things that we can do within a list. And the one that we'll use the most is the use of the add. Okay, so for here we're going to be adding an object to the end of the list. So within a list, what happens is that each item within the list is stored within something called an index, and this index starts at 0. So for instance, if I would like to store 5 items within this list, it will actually start the numbering for the index at 0, and then we'll go 0, 1, 2, 3, 4, finishing at 4, because items 0 through 4 will give us our 5 in total. So that's a bit of an interesting concept to try and conceptualize. So going through and showing that here, we'll go through and add a bunch of numbers into this particular list here. So there are several ways in which we can add them. We'll just go through and add a bunch in like so, and I'll copy and paste them on across. And we've got someone here who's relatively old, someone who's relatively young, and we'll chuck in a couple kind of in between, shall we? Okay, so now we've got a bunch of different elements. So we've got 1, 2, 3, 4, 5, 6 elements in our list. And in terms of the numbering system, what we're going to be looking for here is this is going to be stored in index 0. The one underneath here is going to be stored in index 1. Underneath here we'll be storing this in index 2, index 3, index 4, and index 5. So we do have 6 elements in this list, but they are always 0 based when we deal with lists and arrays, so therefore we'll use up between 0 and 5 as an index to try and refer to them. The reason why we're making a big emphasis on that is because one of the problems that we have sometimes when we deal with lists and try and read them all back to the screen is sometimes we can get out by one error, whereby when we try and list back and show all the items, if we're not careful we might not be able to correctly access and display these back. So that's now added them all in, and if I was to go through and add a breakpoint to my program and try and run it under debug mode by pushing F5, what will happen is that if I put my mouse over the top here, you'll see now we've got a list being popped up, and if I click on the little arrow at this stage, because I haven't run over this line of code, it shows as nothing. But if so by pushing F10 on our keyboard, what we can actually manage to find here is when we go through and take another look at a list, you'll notice that in index 0 we're now storing our first element or first item into our list. So it's storing the value of 10 under index 0. And if I was to just continue on through this process right towards the very bottom, I can show you through my locals window here, if I was to expand this out, the fact that with my list is now containing 5 different elements and it's stored within 0 to 4. Okay, so there's some of our items now, and obviously continuing on would then do nothing with that. Okay, so that's how we can add items into our list. There are other ways which we can do that. So we may choose to look at using or filling up our list with the likes of some kind of loop. So if we're wanting to go through and add a bunch of them, say 10 elements into our list, we could go through and prompt the user to be plugging this in for a set number of times, or we could use some kind of conditional loop to go through and ask the user a set number of times, or until a user plugs in something invalid in which to fill the list. A couple of useful things that we can do once the list items are all plugged in is that we can go through and use some built-in things to allow it to be presented a certain way. We can go through and sort or rank the list. We could go through and use some of these functions to go through and do some basic maths on them. So if I was to go through here and plug in my list and then go through down the list here, you can notice that we've got a whole bunch of different things we can use. One of them is called average. So for instance, this one here is going to go through and average out all of those numbers together. So rather than us having to do those calculations, we could do that simply by using the .average method here. Other ones that are quite useful that we might want to use is the use of min, and conversely the use of max to find the highest number. So we can clearly see the fact that we've got a 100 as our highest item within this list, but if we had a list with say 10,000 items added to it, the use of some of these would be much easier in terms of how we can present this. Other items or things that we can do with this is we could choose to add them together, so we could total all these numbers up. In this situation, if it was a bunch of ages, we probably wouldn't really want to do that. So some of these, while can be handy, not always going to be relevant for the problems that we're working within. So just like within school, a lot of the items that we do cover are teaching you the building blocks for becoming good programmers. We're not trying to teach you to become a commercial programmer as such, but merely just to help prepare you for going on to level 3 in university or tertiary studies, where you'll actually take these concepts to a much higher level. But it's a really good foundation to understand how Visual Basic and other programs will go through and help you to work with the likes of these collections, such as lists. One of the things that we're able to do now when we're wanting to output each of these items is there is an easy way we can simply go through and output the contents of this. And this is something that does catch a few people out, is we're wanting to go through and display my list. Now, if we were to just try and run this, we're going to be generating an error because it's going to get confused in the fact that it won't know which index it should be displaying back within the list, and as a result, as it works through these steps, performs these last procedures, when it gets this line here and tries to output things, we're going to be generating an error such as this one here. So because it doesn't know which index it should be displaying, it will get confused and then generate this. So what we'd like to do instead of using that is to actually push the dot property, and when you come through this list here, we're going to be looking for a particular one called element at, which is one way of doing it. So we're going to be specifying the element at a certain index, and the index that we'd like to use here, say let's show what is in index number 2. So in index number 2, if we then go through and have a little bit of a run of this program, take the breakpoint off, run it right the way through, and you'll notice now that it's output all of those answers. It's found through the average, it's gone through and found the minimum number, it's gone through and found the maximum number, and it's found the sum of those numbers. And this last item here that you can see here is 100, which is, as you can see, the item that is stored at index number 2. To make this more obvious, we could have done a bit of concatenation before each of these were being displayed back. This would make it a bit more obvious perhaps. Okay, so by doing some of these things here, just make it a little bit easier when we're trying to output our results. We'll just alter some of these here. And then lastly, outputting each of those items. Okay, so remember, if you're ever seeing these little errors, we do need to use the ampersand in conjunction with quotes to indicate that we are wanting to add on additional parts to our string concatenation. Same thing at the other end of it. If we're trying to finish with an ampersand, we're going to be generating a bit of a problem because it's thinking something else is expected. So that's basically telling us we've got one too many and or ampersand symbols present. Okay, so running that through again, you'll notice here that it's going to be a little bit more easy to see what's going on with the likes of the concatenation that we've just done. So a little bit of tidying up here. And another useful item that I might show you here is the fact that if we're wanting to fix the number of decimal places, we can go through and use a useful function to try and improve this. Okay, so it's on the average. We're going to go through and use the use of the toString function to convert this average into a string. And inside the quotation marks after the toString or formatting function here, there's a range of different things that we can do. One of the items that we can do is we can format it to show as currency with 2 decimal places. If I go through and run that with an extra parentheses on there, you'll notice that it's gone through and placed the dollar symbol before the 32, and it's also been limiting the precision of this to 2 decimal places. If I was to go through and change it from C2 to P2, this will be showing this now as a percentage with 2 decimal places. Okay, so there's the 2 decimal places, and it automatically concatenates on for me the use of the percentage sign. Other things that we can do, if I don't want any dollar symbols or percentage symbols, I can use F2 to indicate that I'd like a fixed number of decimal points, in this case 2 decimal points being placed at the end of my average. Okay, so you'll notice now with my items here, I've got in index 2, I've got 100 being displayed. Next thing I'm going to do here is go through and sort my list. So I'm going to type in the name of my list, and I'm going to put in the keyword sort here. So what this will do is we'll rank my elements in ascending order, and as a result of this, 100 will be placed at the very bottom here, and when it goes to display index number 2, we'll see a different result appearing than we had before. Okay, so when you look at element that has been now being displayed, it's actually gone through re-rank them, and as a result we've now got 10 being the third highest number. So this is going to be an index 0, this would be an index 1, and this would be an index 2 in terms of a ranked order. So again, if you had a large number of items within your list that you would like to easily go through and rank or sort, this is a useful function to be able to go through and do that. At the moment I'm now wanting to go through and display all of the items in my list back to the user, and several ways in which we can do that, and it's quite common to go through and output the likes of collections such as lists and arrays through the use of counted loops. So I'll show you two different methods in which we can do this. Okay, so for this one here, I'm going to be starting at index number 0, so that will match up with the ranked order that we had before. So it'll actually go through, and because this is now being changed around because of this sort function, in fact I'm going to just comment that out to disable this just so it's a bit more obvious what's going on. So here it is, it's going to output this item here stored in index number 0 to begin with. So therefore when I'm going through and initializing my loop, I'm going to start my index counter as index with 0. And then I'm going to go through all the way through to number 5. So I can go through and plug this in, and then I'm going to simply go through and output the items like you could see here. So by taking this, copying it in the middle here, and then outputting not the use of 2 but changing 2 for the word index, it will mean when it iterates through or loops through this, it will replace the likes of my index that you can see in the brackets for each of these items that it is passing through here from 0 to 5. And the last thing I'll do is I'll go through and replace this down towards the bottom. I'll put a breakpoint on here so you can see how this is going to update and reflect as the program is continuing. Okay, so here it is, we're up to this loop. Index is going to be set to be 0 after this first line is run. There it is, and then when it's going to try and go through and output this, it will show the item listed at index 0, which from this code above you'll notice that it should be showing the number 10. Okay, so going through and doing that, it's now going to pass through and look towards outputting index number 1, which is holding a value of 20. Okay, so it's going to keep going through here, making the index get gradually bigger and bigger until it hits 5. Then it will pass through it one more time, and then we'll pop down to the read line. And when I go through and run this, you'll notice here are all the elements in that order that we listed previously. If we were to go through and run that same process now with my sort uncommented, try and rerun this, it's now going to be in ranked order. No, that did not work. Let's try that one more time. Okay, actually yes, it was working correctly. One of the things that was happening is that this line of code is going through, and no matter what, is still going through and outputting the second indexed item. So I'm going to comment this one out after stopping this code, and if I run it now, you'll notice that we have our ranked order 2 all the way through to 100, and of course the order is changed because of the use of the sort function that I've just gone through and provided here. One of the problems that we had and have this is the fact that sometimes we get a bit confused with knowing how many items are within our list. So for instance, I know that I've got 6 items specified here, so therefore going from 0 to 5 would actually find all of those. If I was to go through and try and show the 6th index, however, this is where I'm going to be running into problems because it's going to be an out by 1 error. Okay, so we'll be getting this error message which says argument out of range exception was unhandled. Whenever you see that, it pretty much means that we've gone too far past our list and it doesn't actually hold that many items. So in this case here it's got 6 elements being stored, and we were trying to go through and show element number 7, which is not available. So a simpler way of doing this, or a safer way of doing this, is to go through and actually use a property of our MyList and we can go through and work out the count of it. Now the count of it will actually go through and find out that there are 6 elements stored here. So we don't really want to go from 0 all the way up to 6 because that would generate the same error. You can simply go through and say, well, whatever the count is, how many items you have, just take 1 off it. Now I find this type of looping a little bit confusing because it doesn't require to remember a wee bit more. So luckily with the use of VB and C#, they actually go through and have a second type of looping structure called a for each. Now a for each is a smart loop. It's a loop that basically knows exactly when to start and when to finish. It does have its benefits, but it also does have its limitations, and I'll show you what those limitations are shortly. So for this, what it will go through and do, it will go through and temporarily assign the value of each of the indexes within our array or our list into this item here. Okay, so it's could be called anything you'd like it to be called. The name is irrelevant. Okay, you'll notice it does have the for next, the same as the counted loop from above, but what this is able to do is it's able to go through and recognize where the starting index is going to be, so index number 0, and it's also smart enough to go through and work out what is the highest number minus 1. So effectively coming through and doing this, copying it underneath here, and rather than going through and doing all this big confusing stuff here, we can simply go through and output the word Bob inside of parentheses. So every time it goes through, it will simply output the item that is stored within index 0, 1, 2, 3, 4, 5, and then it will go through and finish the loop. Okay, so going through and testing this, we'll just block this code out here. Okay, and then you'll notice that we've got our items all being outputted onto our form. Our console window. One of the limitations it does have that a proper counted loop allows us to use is we can go through and use concatenation and actually be plugging back things such as which is the index that it's being used with the built-in index counter already. So if we were to try and do the same thing in here, we would need to create our own counter variable, and we would need to manually iterate through this through the likes of our program. So this is where it gets a little bit clunky to try and do the same thing. Okay, remembering that we can either do the likes of counter equals counter plus 1, which is going to remember what it used to be and just add 1 to it, or we can use the shorthand method of doing the same thing. So if I was to want to go through now and output this, okay, so there's a bit of concatenation there. It's going to be using the word counter. It's going to output the counter variable, which is going to be set as 0 to begin with, which is the same as my starting index for my for each loop, and then it's going to output the contents of my variable Bob here, each iteration through or pass through of my loop. Okay, so let's go through and run it. Here it is. So at index 0 we're holding 2, at index 1 we're holding 5, etc., all the way through down towards the bottom. So using that additional step seems a little bit clunky when I'm trying to do that type of thing, so that's where the use of my counted loop here is probably going to be a more natural use. Now in terms of which one you prefer to use, does it make a difference? No, it doesn't. They're both going to do the same thing. If the for each loop is easier for you to remember, which in my view it is, feel free to use that. If you are happy using a traditional counted loop, you can go through and use that one there. Conversely, if you'd like to use some kind of while or conditional loop, you can go through and do the same thing using that. The standard just requires you to use a loop in some form. Okay, so those are effectively the use of lists, and we can do some useful things with the list concept, such as working out lotto numbers. Lotto numbers that are generated could be added to our list. One of the things with lotto that we'd want to make sure of is that if there is a list containing an item already, or item already in our list, we would want to generate another one. So one of the concepts that we can use in here is working out if a list contains something already. Now the way that we would do that is through some kind of if statement, and if our list already contains something, we would be given a message. Okay, so let's go through and maybe ask the user to be plugging in an item. Okay, so let's go and get the user to add something in here. Okay, so I'll prompt the user here to please type in a number. And we'll store that into the user input. Alright, now that we've got that, we're going to go through and check to see whether this input is actually stored within here. Now of course we could go through and check to make sure it's a valid number through the likes of our try-pass techniques that we've already covered. We could go through and make sure it's within a valid range, which is one of the requirements for stepping up into merit, and we can also be going through and checking a whole range of other things. But just let's go through now and see whether our list already contains it. So okay, so we use the term here, let's check out my list, and let's see if it contains the word, the input that's been plugged in. If it does, all we'll do is we will just output some kind of statement. Okay, so we see that we've got an number 20 being plugged in here, so let's go through and just check this out. So if I work on 20, it's going to say that it is already in the list, and then it continues on with my code. If I was to go through and put a unique number in here, such as 21, it's going to show as being not in the list. So with that concept there, we could choose to go through and do things such as, well, if it's not in the list, let's go through and add it to the list. And then down towards the bottom here, it's going to be smart enough to work out, hey look, let's go through and output this as well. It's going to be sorted and then shown towards the bottom. So let's put in a number that's really big and different. So let's put in 200, which is not in my list already. And you'd expect 200 to be at the very end as well. So the first thing it's going to go through and do is check to make sure that it is not in the list. It's going to be part of this calculation here as well. It's going to go through and show at the bottom of each of my lists when I iterate and count them out through the outputting. And that's pretty much how we can work out whether something is in a list or not. Now obviously if it is already in the list, what we might choose to do is ask this question again. So if we're not happy with that situation with having a repeated element, we would go through and structure this through some kind of loop. So while input is not in the list, we want to keep going through and asking the question. As soon as they maybe add something that's in the list, maybe the program finishes. So that's where us as developers and programmers get to have a bit of fun and think about the logical nature of our programs. Okay, so that's pretty much the use of lists in a nutshell. I thought what I'd do now is show one of the examples that we've done in class already, such as the lotto problem, which is something that allows us to add a bunch of random numbers into a lotto list, and the numbers need to be within a certain range. So in order for me to do this, I'll just take a little break and I'll set up our new project ready to go.